So back to steric number 6. Steric number 6. 6 bonded atoms. This would be octahedral, and no matter how you turn it, every bond angle should be 90. So there are no axial and equatorial positions if it has a steric number of 6. All right, so next thing, we start substituting. We take off a bonded atom and add a lone pair of electrons. Okay, we get something like this. And we're going to call this a square pyramid, or square pyramidal shape. Pyramidal. What's that? Bond angles? 90. There's nothing else. There's not. This might bow upward a little bit. So that bottom, it might be a little bit slightly less than 90, because the electron density is greater for the lone pair than for the bonds, but not much of a change. Next thing is if we take off 2. Now, when you take off 2 atoms and you substitute in lone pairs, you do have to add your lone pair at a specific point. You should not put your lone pairs of electrons next to each other, because the electron density is greater for lone pairs. They need to spread out as much as they can. So we should take the one that's opposite the other lone pair, and it needs to be like that. So you should end up with something that makes a square. It's in a plane. We call it square planar. And bond angles are still 90 degrees. Next thing, take off. Now the third one we take off doesn't matter a whole lot. They are equivalent. We take off 1. We have 3 lone pairs. We have 3 bonded atoms. And once again, we end up with something that is T-shaped. So note, T-shaped exists for a steric number of 6, and T-shaped exists for a steric number of 5. Both of them have 3 bonded atoms. Just careful with your steric numbers. Next thing is if we take off 1 more, we are going to end up with a linear molecule. It is, for the next one, for the 4th lone pair of electrons that you add, it needs to be this one. It can't be over here, because that would bring it closer to more lone pairs. So you can kind of see that if you, right, like if I add this lone pair here, it's close to 2 lone pairs. But if I added this lone pair where this atom is, it would be 90 degrees from 3 lone pairs. So it does need to spread out as much as it can, and it does this. This is how atoms within molecules act. But we end up with something that's linear. So to point out, a linear, and the bond angle is 180 degrees, there is a molecule molecules with steric number 6 that are linear, molecules with a steric number 5 that are linear, and molecule with a steric number of 2 that are linear. But for steric numbers 3 and 4, they end up bent if you have just 2 atoms attached. So just something to recognize. All right, so there's your chart. Practice that.